that gamma ray bursts do happen rather far away. They're definitely extragalactic, as in we don't really have them going on in our own galaxy, which is probably a good thing because they're extremely big explosions. They involve extremely big explosions. So okay, perfect. Okay, yeah, no, good. All right, let's look at this introduction. Gamma ray bursts are the most luminous transient events in the observed universe. So they are the most luminous transient events. So what does transient mean? Transient means that they're temporary. They're not something that is there and it just keeps on happening for a very long time, but more like a transient event, right? But they're the most luminous. When they occur, they outshine an entire galaxy. That's how much luminosity a transient event like a gamma ray burst can emit. Gamma ray luminosities of gamma ray bursts are of the order of 10 to the 52 ergs per second, which can be compared to the 10 to the 33 erg per second emitted by our sun. So our sun's energy output is 10 to the 33 ergs per second. A supernova is 10 to the 41 ergs per second. And a whole galaxy is something like 10 to the 45 ergs per second. And here's a gamma ray burst, which is the order of 10 to the 52 ergs per second. Now, a gamma ray burst, it's a short duration. We will talk about the specifics of all, the durations of a gamma ray burst. But it's short, but for the time that it is occurring, it basically outshines an entire galaxy. First discovered in 1967 by the Vela satellites. Let me take a clip of this. First discovered in 1967 by the Vela satellites, flown by the US Department of Defense, gamma ray bursts continue to intrigue and puzzle scientists to this day. However, research in the past decades have revealed much about them, including that they are extragalactic in origin, isotropically distributed, and that they come in at least two populations. So that's the thing. So they were basically, during the Cold War, they were discovered by the US Department of Defense, by the Vela satellites flown by the US Department of Defense. They picked up on these gamma rays basically, and they thought, oh my gosh, is this something that, some country of interest is doing? But actually they turned out to be a natural event. But yeah, those are the main points. They're extragalactic in origin, isotropically distributed, as in they're not necessarily, they're not specifically coming from a specific direction in the sky. They can have an isotropic distribution, and they come in at least two populations. Gamma ray bursts are classified as long if they last for greater than 2 seconds, and short if they last for less than 2 seconds. So for 2 seconds, the gamma ray burst outshines an entire galaxy. We'll get into more details of there's actually an afterglow and all that stuff, but basically they're transient events. So it's not like once this gamma ray burst happens, you can observe it at that same intensity for many, many minutes or days or whatever, although there is a part that we can observe later on at a different wavelength. But for those very short periods of time, depending on the length, if it's greater than 2 seconds, it's called a long gamma ray burst or a long GRB. If it's less than 2 seconds, it's called a short GRB. Long bursts are associated with the collapse of massive stars or hypernovae. So these are just supernovae that are really, really big. So like massive stars collapsing, probably when these massive stars collapse. So you were right. Someone said, I think it was Stephen, who said that they might become black holes. So basically, gamma ray bursts are not a black hole yet. Basically, massive stars collapsing, producing a supernova, hypernova type of situation, ultimately might collapse to a black hole. But before that point, this gamma ray burst phenomenon is happening. This transient event is happening. So the long GRBs are associated with the collapse